Measure here. Took our first pass with the finished tool. About 14.5 thousandths still to come out of the bore. I set it undersized, so what I want to do is I'm going to take another pass at about 8 thousandths, and then we're going to measure it again. First diameter, see where we're at. Okay, we got about, I don't know if you can see that there, about 4 thousandths to go. Maybe a couple of tenths more than 4 thousandths on that bore. And we have, this is all the way in the back, got about the same. Make sure I'm in there all the way. Maybe a hair less. It's more or less the same. So now we have to decide on how much to bring it out to size. Now, with these, with those silent bars like that one, they tend to flex, and you can't just. The common sense would say, let's just take it out another 4 thousandths, but it doesn't actually work that way. I've been noticing that this particular bar on this bore, see, I'd take a first cut like you saw, and then I take a second one, and I try to leave about the same amount of stock to come out for my final finish pass, between 3.5, 4 thousandths, which is about what we have. So, but if I took it all the way, that 4 thousandths, it would be almost oversized, is what I've been finding out. So I'm going to take 0.003, I'm going to take 3.2 thousandths, even though we got about 4 thousandths to go. I want to go undersized about 8/10 thousandths of an inch. Let's see where that ends up making us. And then we're going to rerun it. And this should be our final pass on the bore. Let's just check the depth, just to be safe. Well, the depth's been running pretty good. Let's check the zero on this. Pretty close. Not gonna worry about 1/2 thousandth. Okay, that's within 1/1000th of an inch. I'm not gonna worry about that. It's in tolerance, plus or minus 5. So we're gonna be all right. And if anything, rerunning the bar will take just a little bit more out of it. So now I've adjusted the offset. We're going to rerun the finishing bore. Pretty much right on size at the front. The back is maybe 1/10 of a thousandth, almost 2/10, a little bit smaller. Right on size. In the very back of the hole, this dial indicator is set to. It's about 1/10 of a thousandth, maybe a hair more than that, above nominal. So that's all in tolerance. In fact, well within tolerance. So you can see that you can't just adjust that bar out to the full size, because there's always a little bit of pressure against the tool when it's cutting, and it cuts different than the size you might think. Particularly on the finish, the last finish passes, it does this kind of thing. So you got to be a little bit careful. You can't just run this tool, these silent bars here, like immediately right to the size on a one finish cut. You have to kind of do multiple cuts, or like I said, you have to if you have a lot of parts and the parts are not expensive and you're not too worried, you can balance the roughing cut from your roughing tool to make it take just the right amount of stock with your finish tool so that you come out to size with one finished cut. But that's kind of a little tricky to do, and you have to keep track of your roughing insert a lot with that. You got to make sure that it doesn't get dull and push off too much, because then your finish tool is going to take more than it's supposed to, and it can actually cut oversized, or it cuts undersized, and then you can't just rerun a spring pass at that setting, because then it is going to cut oversized. You have to actually, if you're going to do it that way, you have to actually set the tool down for your spring pass, if that makes any sense. It's kind of strange, but that's the way these tools act. So I just thought I'd show that. Once you get used to it, it's not difficult to do it, but it's kind of like you got to run some parts and kind of get a feeling for the particular part you're running and how much it's going to need to change the offset to come to finished size. All right, let me see where we're at here. Put it in the groove. All right, I'm happy with that. It's right in the middle of the tolerance. Perfect. My battery ran down right at that last part of that shot. Let's go in here and check. This is that gauge that I made the other day. Get it in the groove. Looks like we're right on the money there. It's plus or minus 5 thousandths. This is not really a close tolerance on this diameter, but I need to check it. Kind of explain what's happening here. What I do is I program a helix that's one revolution, and it's the pitch of the thread going in and Z, and I start with the tool right at Z0 here. And so I want to put this blunt start going one revolution down on the thread, but I have to get it in the right place in relation to the thread. And what I do is I run it in like this. And I've already done this, so I'm not going to redo it, but I was just going to explain it here. I've already set the offset, but I run it in like this, and then I look where the start of this thread starts. And it's kind of easy on an Acme thread because it has a flat, it has a flat major diameter on this ID thread on it. And so you don't have to be too precise. If this was like a V thread, you'd have to be a little bit more careful, and I look where the thread starts on the face of the part, and then I if it's off, like let's say it's rotated over here, which it was the first time I ran this, and I have this on a separate fixture offset, G55. The rest of the part is running on G54. So I adjust the C0, and in the case of this, I had to rotate it back this way 30 degrees because this start of this thread was way over here. And I want the helix to start right at the start of the thread in an appropriate place to make this blunt start. and then I do one revolution, which is going to be the C-axis rotating in this case, but the Z is going in for that rotation, one pitch of the thread, which on this 8-pitch thread is 125 thousandths of an inch. And then it's gonna drop down and come back, and it's gonna do a roughing and a finish pass on that, rotating the C-axis only. This tool stays on center line in Y in this case, because it's a rotating of the rotary axis type of a milling path. So that's how I line up on it. I let it come up to this point just like you see it here in single block, and then I usually mark with a felt pen out here, like a Sharpie, where the beginning of the thread is, so I can see it. And then I can guesstimate how much to rotate my fixture offset, and I make that adjustment, and then I run it back down here and see where my mark ends up in relation to my end mill. And if I got to make any more adjustments, I do that. And like I said, with an Acme thread, it's pretty easy because there's a flat here, and you don't have to hit it perfectly. With a V thread, you got to be a little bit more careful with it. And it's not hard to do, and that's as easy as it is to get this blunt start just in the right place. And then it repeats for every part after that. You don't have to readjust it after you've got it set. This diameter here has to have a 32 finish on it. And that first groove is back there where you see that kind of little step, and then that other groove that I measured with my tool that I made is back further. I don't know if you can see it back in the, just barely make it out back in the smaller bore. So the part, the reason this part got kind of delayed, or I had to kind of stop on the job, was this diameter here on the new part actually had a thread on it, and this was a shoulder, a square shoulder, but they changed this part to have nothing on the OD, and then they wanted this taper. And I cut that big groove in there to avoid the intermittent cut of cutting into this slot. But in essence, that didn't do me any good, because then I had to cut the chamfer or the taper out to the OD into it anyway. So I programmed that like you saw in the video previously. But they, due to some kind of a design change, and also there was a material change. They changed the material as well, but they decided they could use this same material after all. And they let us just do this. Now there was also a little pin that goes in this square shoulder that's no longer in the part either. And this hole, there was a hole in the bottom of this this slot that goes down in here. And they didn't want that in there. Let me blow it out with the air a little bit. Right there, get a light, maybe you could see it better. There's a slot, there's a notch that I cut, you saw in the previous operation. And there was gonna be a hole, a port right here. And I'd have to come in here and mill this flat with an end mill. That's why I did it like I did it, because I needed to put this in here, but I wanted to put this hole in here after the turning. I didn't want to turn into the hole, and so I didn't want to do this in the first operation. I wanted to do it in the second operation, but it turns out that they did away with that feature, but they could live with this being the way it is now because of the misunderstanding or the design change. I don't know what it was, but somehow the information didn't get relayed, at least to me for sure, but it wasn't really my fault. They're not saying anything about it. They just allowed me to just turn it like this, finish the parts. So that's the finished part. for the final operation. Not too big a deal, really. This is just a turning operation. Maybe I can get a better, maybe you can get a better look at that blunt start. If I rotate the part, I don't know. Got so much coolant on it there. It's right there. See it right there? Because they have this taper, I think it actually looks better when you make these blunt starts if you don't put a chamfer on the beginning of the thread like they've got here, but they've got that specified in the drawing as well. So I had to do that. If you just put a chamfer at the angle of the half the 29 degrees and then put this blunt start, it kind of looks more like a gauge does, like if I show you this, more like this blunt start looks. But anyway, that's the last operation on this part, it turns out. It actually made it easier, their change.